So here's a question on halogen reactivity. I'm going to work through it together by analysing how we'd kind of answer this kind of question and picking out some of the key ideas. So first off, let's read the question. The halogens are group 7 in the periodic table. Explain the trend in reactivity of the halogens, and it's worth 6 marks. That's the first thing I would do. The next thing I would do is make sure I'm really clear with what the question's trying to ask me, okay? So I'm happy with this idea that this is group 7. So if I look at the periodic table, I'm looking at group 7, which is this column here, okay? The word trend, or the word trend means pattern, okay? So what's the pattern in reactivity of the halogens here? And reactivity, well, whenever we're talking about reactivity, we're talking about electrons. It's the electrons that are responsible for a reaction, and an electron's responsible for bonding. So whenever we're looking at that, this is what we think of. Explain, well, this means, first off, it's not even told me what the trend is, so I need to say what the trend is, but then explain why. Why is this the trend? Okay? And hopefully by doing that, I'll get towards my 6 marks. So first thing I always do whenever I'm not quite sure how to answer a question is I'll do this, and then if it's about reactions, I will draw the electron configuration. So in group 7, I've got fluorine with 9 electrons. I'll draw it, draw the electrons, because that's what makes it react. And below that is chlorine with 17, and again, I'll draw it. Now hopefully, I will start to see the pattern. And if I'm not sure what the pattern is, well, we'll come to that in a minute. So first thing I can do, I can make some statements about what I can see. Well, all halogens have 7 electrons in their outer shell, and that's why they're in group 7. Next up, I'll be thinking, well, why do these react? Well, they've got 7 electrons in their outside shell. Well, they all want 8, because that's going to give them the electronic structure of the noble gases. That's going to give them a more stable electronic structure. So to get 8, they're all going to want to gain 1 electron. So halogens have 7 electrons in their outer shell. They want to gain 1 electron. I know electrons are negative, so if I gain 1 electron, I'm gaining 1 negative. Therefore, when they react, they will form ions with -1 charge. Because if they've gained an electron, they've gained an extra negative. So hopefully what you've seen that I've done so far is I've not really used any knowledge. All I've done is drawn the electron configurations. And from the electron configurations, I've got to this point here. So even if you don't really know what to do and you're talking about a reaction or bonding, draw the electron configurations of the things that you've got, of the elements you've got. So, if this fluorine gains an electron, well, electrons are negative. Or if this chlorine gains an electron, that electron's negative. So that's why they react. Now, we're trying to now get the pattern of which one is the most reactive. So this electron's negative, and the nucleus contains protons and neutrons. So those protons and neutrons, or protons are positive, neutrons are neutral. So overall, the nucleus is positive and the electron's negative. So we have an attraction here between the electron that it's trying to gain and the nucleus. So now which one's going to be most attracted? Well, clearly, fluorine, this electron here is going to be more attracted to the fluorine because it's closer. whereas this electron here is further away. So let's try and put this into words now. So going back to the question, it says explain the trend in reactivity. Well, first thing I need to say what the trend is. So the top of group 7 is most reactive, and this is fluorine, and it gets less reactive down group 7. So that's just stating what the trend is, or describing what the trend is, what the pattern is. The question says it needs to explain. So now, let's explain why. So why is fluorine the most reactive? Well, first point, the outer electron further down group 7 is further away. And if it's further away, it's going to be, therefore, less attracted to the nucleus. So there's one reason. Second reason is that on the fluorine, between the electron it's trying to gain and the nucleus, there's only one shell in the way, like one shell blocking the attraction. Whereas in this, there's two shells in between the chlorine nucleus and the outer electron, so there's two shells blocking the attraction. So we call this shielding. So because they're blocking the attraction, there's less attraction. So down group 7, there are more shells between the outer electron and the nucleus. We call this shielding. So shielding is your key word here. So now I need to kind of bring this all together so that it makes a bit more sense and use these other keywords that I need to include. So yes, the electron's further away, and yes, there's more shielding. So therefore, if the electron is further away and has more shielding, it will be less attracted to the nucleus. If it's less attracted to the nucleus, it will be harder to gain. And remember, what they're all trying to do, they all want to gain one electron. So if it's hard to gain it, it's not going to react very well. Let's read through to check we've answered the question properly. So the halogens are in group 7. Yeah, I'm happy with group 7. I've got fluorine, chlorine, bromine, iodine. Might even put those in. Explain the trend in reactivity. Trend means pattern. So the pattern is the most reactive is at the top, the least reactive is at the bottom. And I need to explain that. So halogens have 7 in their electrons in their outer shell. Good. They want to gain 1. Electrons are negative. Therefore, they'll form an ion with a -1 charge. So I've stated the trend. Group 7 is the most reactive, and it gets less reactive down. Now the explain bit, the why. Well, the outer electron further down group 7, because these get bigger as you go down, is further away. If it's further away, it's less attracted. Also, down group 7, there are more shells between the outer electron and the nucleus. We call this shielding. Therefore, if the electron is further away, so we've got this idea further away, and there's more shielding, it will be less attracted to the nucleus, and it will be harder to gain. So therefore, fluorine, because the electron's really close and there's less shielding, it's easy for it to gain an electron, therefore it's really reactive.